Okay, welcome back everyone. Let's get right into it. Today, we are tackling a massive, undeniable truth about Cambridge mathematics. Whether you are sitting for the IGCSE 0580, the O-Level 4024, the Additional Math 0606 or 4037, right up through to AS and A-Level 9709, and Further Math 9231, there is a fundamental secret to securing top grades. And it's this. We are going to completely demystify Cambridge mathematics by treating your exam paper not as a standard math test, but as a formal legal brief. Think about it for a second. In a courtroom, a lawyer doesn't just stand up, shout out a verdict, and expect the judge to agree, right? No, they have to build a logical, structured argument based on rock-solid evidence. That is exactly what we are going to do today with one of the most absolutely critical topics across the entire syllabus, solving simultaneous equations where one is linear and one is quadratic. To set the stage, I want you to picture a real past paper question. We are looking at a classic intersection problem, and I want to introduce you to two types of students we see all the time. First, we have Alex. Now, Alex knows every formula in the book. Alex overloads the exam paper with raw mathematical facts, writing down the quadratic formula, the discriminant, expanding brackets left and right, but there is zero analytical structure, just a chaotic brain dump. Then, on the other hand, we have Sam. Sam is quick, but Sam rushes entirely, completely missing the specific command word requirements, doing the calculations in the margins, and just slopping down a final coordinate at the bottom of the page. When the red pen comes out, both Alex and Sam lose massive marks, not because their math was inherently wrong, but because they failed to build a legal case. Today, we are going to fix that. Now, take a really close look at this quote straight from the principal examiner reports. Mastering quadratics is essential for Cambridge mathematics. This topic appears in every examination series. What is incredibly interesting about this is that it establishes the absolute, non-negotiable high stakes of mastering one linear and one quadratic simultaneous equation. We aren't talking about some obscure niche topic that only shows up once every 5 years if you happen to get an unlucky paper. No, this is foundational architecture. It appears in every single examination series, across 9709 and the other syllabuses, because it rigorously tests your fundamental algebraic manipulation and your logical stamina. This is the ultimate test of your mathematical argument. It is a mandatory requirement for your case. The examiners are actively, almost ruthlessly, looking for very specific evidence of your mastery before they award those top marks. They want to see that you can cleanly isolate a variable, substitute it flawlessly without dropping a negative sign, expand a binomial without panicking, and factorize the resulting quadratic to find distinct roots. If you treat this like a casual calculation, you are going to get destroyed in the courtroom. But if you treat it as an opportunity to showcase an undeniable chain of logic, you're going to secure those top grades. Here is the roadmap for our strategy session today. 1. The mathematical case brief. 2. Securing method marks. 3. The standardized execution sequence. 4. Deconstruct, solve, evaluate. And 5. The examiner's verdict. Let's start with Section 1, the mathematical case brief. To begin building your undeniable case, you have to truly understand what the judge, in our case, the Cambridge examiner, is actually looking for. And the crucial point here is that academic benchmarks in this subject strictly prioritize analytical depth over a superficial breadth of knowledge. It's time to break down these assessment objectives. The examiners do not just want to see that you've memorized a vast menu of formulas and can randomly plug numbers into them hoping something works out. That's exactly what Alex does, and it fails every time. They are assessing your ability to decode command words. When a question says solve algebraically or show that the line is a tangent to the curve, those aren't just suggestions. They are strict legal mandates. Show that means the final answer is already known, and your entire grade depends 100% on the analytical depth of your intermediate steps. They want to see how well you can dig into the core mechanics of a complex problem, like finding the exact coordinates where a straight line intersects a parabola, and follow that logic without breaking the chain. You need to prove, step by step, why your math is undeniable. So how do we actually do this? The absolute best candidates build their case using what we call the Peel framework, adapted specifically for Cambridge mathematics. Peel stands for point, evidence, explanation, and link. In math terms, that translates to state the principle, show the equation as evidence, execute the calculation clearly, and link it back to the context. This brilliantly illustrates how top-performing students exhibit connected conceptual understanding. They take the theoretical architecture, like knowing that a tangent implies the discriminant equals 0, and they integrate it seamlessly. I want to do a quick interactive challenge with you right now. I'm going to describe two approaches, and you have 30 seconds to spot which one follows our Peel framework. Approach A. The student writes down y equals 2x plus 1, immediately writes a massive expanded quadratic, and then writes x equals 3. Approach B. The student explicitly writes substitute linear equal into quadratic equal, writes the substitution step clearly, equates it to 0, states, use quadratic formula, and clearly lists the 2x values. Which one wins? Obviously, it's approach B. That is the Peel framework in action. Before we continue and dive into how to transform your own answers, subscribe to our YouTube channel Ace the Exams at aceexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Let's move into Section 2, Securing Method Marks. Welcome to the transformation. If you take only one singular thing away from this explainer today, it has to be this core principle, the method mark strategy. Let's bring back our students, Alex and Sam. We are going to rewrite their answers live. Alex previously lost marks by dumping raw facts. We fix this by introducing the mathematics success blueprint. We take Alex's scattered quadratic formulas and structure them. We force Alex to clearly write out the substitution step before expanding. Suddenly, the red marks turn into green check marks. Then we look at Sam, who rushed and missed the command words. Sam got the right final coordinate, but lost 70% of the marks. Why? Because you are evaluated on the quality of your evidence and your procedure. The examiner must see the transparent process of how you arrived at your conclusion. A final numerical answer standing all by itself on a blank page is exactly like a lawyer making a massive dramatic claim in court without presenting a single piece of supporting evidence. It gets thrown out immediately. Marks are awarded for the process, the logical reasoning, and the correct application of principles. So we make Sam slow down, show the rearranged linear equation, show the expansion, and show the factorization. Boom, full mark secured. All right, Section 3, the standardized execution sequence. Stop scrolling, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now we are entering our interactive workshop phase. To guarantee those method marks we just talked about, we have to look at the strict rules of evidence. This is the exact standardized sequence you must follow. Step 1, identify key elements. Which is the linear equation? Which is the quadratic? Step 2, apply relevant principles. This almost always means making x or y the subject of the linear equation. Step 3, execute analysis with absolutely clear working. Substitute that subject into the quadratic equation and expand carefully. Step 4, verify results. Step 5, present in an appropriate format. Let's do challenge 1, data scan. Imagine a complex math problem on the screen. It gives you a straight line equation and a curve equation, but they are all jumbled up with fractions. You have 60 seconds in an exam to extract the core trend. What do? You multiply out the denominators. You get everything on a flat single line. Now, challenge 2, find the flaw. Listen to this sample working. The student substitutes y equals 3x minus 2 into x squared plus y squared equals 10. They write x squared plus 3x minus 2 squared equals 10. Next line, x squared plus 9x squared plus 4 equals 10. Where's the flaw? Did you catch it? They completely forgot the middle term when expanding the binomial. They missed the minus 12x. That single sentence loses all downstream accuracy marks. The examiner commentary here is brutal. Candidates frequently fail to expand binomials correctly, resulting in a total loss of accuracy. You have to follow the sequence carefully. Moving right along to Section 4, deconstruct, solve, evaluate. Now we transition into the cross-examination phase. How do you rigorously problem-solve these complex, simultaneous equations under strict high-pressure exam conditions? Think of this chronological workflow as a top barrister deconstructing a tricky witness statement. Let's do challenge 3, speed writing. You have 30 seconds to mentally map out a perfect Peel paragraph for solving. Go. Phase 1, identify given information clearly. Phase 2, break it into logical steps. Deal with one variable at a time. Phase 3 is solving systematically. Keep your equal signs aligned down the center of the page. Do not jump erratically from the top left corner to the bottom right corner. Phase 4 is absolutely vital. Check for reasonability. If you are calculating the intersection of a line and a circle and you get imaginary numbers for your roots, what does that mean? It means the line doesn't intersect the circle. Is that reasonable given the context of the question? If the question said, find the coordinates of intersection, you know you made a calculation error. Go back and fix it. And finally, Phase 5, make justified recommendations, meaning write out your final formatted coordinate pairs clearly at the bottom. X equals this, Y equals that. We are now entering our final system protocol. Because higher order Cambridge assessment demands evaluation, you must evaluate the quality of your own mathematical evidence. Here is the ultimate cheat sheet recap, our 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, Peel framework application. Rule 3, time management matrix. When you are deep in the working, you have to consider limitations and assumptions. For example, let's say your quadratic equation yields two values for time, t equals 5 and t equals -2. A superficial student writes down both. An analytical student, acting like a top barrister, states the assumed initial condition. Time cannot be negative in the specific physical framework. They explicitly write reject t equals -2 and evaluate the effects on the final conclusion. Recognizing these exact constraints and alternative interpretations is the secret sauce. It is what separates an average passing grade from the top-tier outstanding candidate in the eyes of the examiner. Finally, Section 5, the examiner's verdict. Let's open the doors to the jury deliberation room and look at the insider evidence. These are the top pitfalls that will completely destroy a student's case. Even if you have perfect underlying math, failing to use the appropriate presentation conventions will cost you the verdict. Look closely at these unforced errors. Forgetting proper layout, like just scattering numbers everywhere, loses you incredibly easy method marks because the examiner simply can't follow your logic. Candidates consistently fail to provide answers specific to the given context. Remember our example about rejecting negative time or a negative length for a geometric shape? If you leave it in, you are telling the examiner you don't actually understand what the math represents in reality. And a huge red flag, confusing key terminology. If a question asks for exact form and you write down a decimal, you lose. If it asks for coordinates and you only write the x values, you lose. These are the details you must lock down. Before you walk into your next exam, I want you to look at this question and reflect deeply. Are you just finding the answer, or are you building an undeniable mathematical case? Shifting your mindset from mere calculation to logical case building is the true ultimate secret to Cambridge mathematics mastery. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.